When a capsule of Broncho-Vaxom is ingested with some liquid, it travels through the throat and the esophagus to finally reach the stomach. The stomach, where the capsule, due to the local acidic conditions, is degraded and its active ingredients are released. These active ingredients are modified pathogen-associated molecular patterns that will pass into the small intestine. They'll diffuse through the intestinal villi, probably via the M cell, to finally reach the Peyer's patches. This immunological organ is a non-organized lymphoid follicle containing immune cells like dendritic cells, macrophages, T and B cells. The dendritic cell uptakes and processes the Broncho-Vaxom antigens to present them to naive T cells, which then become activated. The Broncho-Vaxom activated immune cells then migrate to the closest lymph node, called the mesenteric lymph node. While migrating into the lymph node, the activated T cells then differentiate into T helper 1 cells or T helper 2 cells, able to promote either phagocytosis or antibody production. Here is a representation of an activated helper T cell activating a B cell, which then becomes a memory B cell or a plasma cell, able to produce specific antibodies, like immunoglobulin A. All the Broncho-Vaxom activated immune cells and secreted antibodies therefore migrate via the blood and the lymph vessels to other lymphoid tissues of the body, such as the one of the respiratory tract. The various immunological organs of the body are connected via lymphatics and blood vessels, and so a response generated at the intestinal level can be transferred to other mucosa by a system called the mucosa-associated lymphoid tissue. Once the immune cells have reached the lungs and bronchi, a phenomenon called extravasation or diapedesis allows the immune cells and immunoglobulin A antibodies to reach their effector site. Indeed, the respiratory tract is the place where infections initially occur, when bacteria and viruses have overcome the first line of immune defenses. Therefore, immunoglobulin A antibodies and immune cells will be able, in the respiratory tract, to recognize and fight those pathogens. Immunoglobulin A antibodies will recognize and coat, in this case, a bacteria. This process, called opsonization, will then allow the macrophages to identify the opsonized pathogen, to engulf it and destroy it in order to overcome the infection.